Hi, I want to talk to you about vectors and scalars. This is going to be really important throughout the year because pretty much everything that we measure can be classified as either a vector or a scalar. So let's start out with scalars because that's what you're most familiar with. That's what you've been using in the past traditionally. A scalar is any sort of measurement that has a size but not a direction to it. So if you want to see how far you walk to the mall, for example, maybe you walk 2 miles, that would be a distance that is a scalar. You look at your car has a speedometer on it. The speedometer measures your speed, how fast you're going. That is a scalar quantity. But there are also what we call vector quantities. And vectors are a size, a measurement that has a size and a direction associated with it. And the size of it is often called the magnitude. So we can talk about the magnitude of a vector, and the magnitude of a vector is just the size without the direction. So if you look at your car, for example, your car has a speedometer that measures your speed. If we want to look at a vector that represents the same thing, that would be velocity. So velocity would be like you're going 60 miles per hour in a certain direction, east, for example. The magnitude of that vector would be 60 miles per hour. That would be your speed, but your full velocity would be 60 miles per hour east. In this class, we'll often use meters per second too. Doesn't matter, they both can be classified as scalars or vectors. Distance has a corresponding vector to it also, and that is called displacement. So distance might be how far you travel. Displacement would be how far you end up from your starting point with a direction associated with it. So if I walk 4 steps in that direction, 1, 2, 3, 4, and then I walk 2 steps back, 1, 2, I've gone a total of 6 steps. So the distance I've traveled has been 6 steps. But my displacement, that would be my change in position, would be 2 steps in this direction, meaning I've come a net of 2 steps in this direction, even though I've traveled 6 steps because I've gone 4 and 1 and 2 backwards. A lot of scalars and vectors don't have corresponding quantities. Scalars include time and energy and mass, for example. Many of the other things that we'll see too, most things electrical are scalars, most things related to waves are scalars. The constants we deal with are almost all scalars, with a couple of exceptions. But there are vector quantities as well. So acceleration is a vector quantity measured in meters per second squared. Force and weight. So again, don't confuse weight and mass. Mass is how much matter is in a material. Weight is a force. It is the force of gravity pulling down on you, which is why it's often expressed as F sub g. So because weight is a force and force is a vector, that means weight has also got to be a vector. And in this case, your weight pulls you down towards the center of the earth. So I might weigh 600 newtons downwards, for example. The magnitude of that would just be 600 newtons, but it would be a downward force. And momentum and impulse are also vectors. We're going to learn about more of these as we learn about the different units, but it's worth memorizing these so that you know which are scalar quantities and which are vector quantities. Thank you.